Hello everyone, my name is Lauren Zielinski. I work on implementing environmental flow projects, particularly through the use of monitoring and adaptive management. I have a background in environmental engineering and ecohydrology and also have experience in stream restoration and environmental assessments. I am from the United States and have worked in the US, Africa, and Europe, like in this photo where I am helping with a trout repopulation effort in Poland. As part of this unit on implementing environmental flows, I'd like to present a case study of a dam-scale environmental flow effort that has recently been implemented on the Roanoke River in the southeastern United States. This example is especially interesting because it is part of an ongoing effort between a federal agency and a non-governmental organization to implement environmental flows across the United States. The United States Army Corps of Engineers is the largest and oldest water resources management agency in the country, and the Nature Conservancy is an environmental organization focused on science-based and collaborative approaches for meeting the needs of both people and nature. These two organizations teamed up to start the Sustainable Rivers Project, or SRP. The program officially began in 2002 as an effort to minimize the effects of dam operations on rivers while still being able to provide for existing dam objectives, such as hydropower and flood control, using adaptive reservoir operations. The SRP selected 8 demonstration sites across the country with a variety of river and management conditions to develop a range of water management methods, tools, and practices that could help environmental flows be implemented across the country. One of the 8 SRP demonstration sites was the Roanoke River. The Roanoke River runs through the states of Virginia and North Carolina in the southeastern United States, running 400 miles or 660 kilometers from the Blue Ridge Mountains to the Atlantic Ocean. The watershed is mostly rural, and the river is known for its surging spring flows and mostly intact ecosystems, including bottomland hardwood forest ecosystems located in the coastal plains close to the mouth of the river. Due in part to its abundance of water, there are 6 dams located on the Roanoke River. The most downstream of these dams are the Kerr, Gaston, and Roanoke Rapids dams, which are the focus of this environmental flow effort. While there are 3 dams in this complex, the John H. Kerr Dam is the main focus of the SRP because it is managed by the Army Corps and is also the largest reservoir in the group. The Kerr Dam is located on the border between Virginia and North Carolina and forms Kerr Reservoir, a 50,000-acre or 200 square kilometer reservoir. The reservoir is managed for a variety of reasons, including hydroelectric power, low flow augmentation, fish and wildlife, water supply, and recreation. These management objectives were established through various legally binding acts passed by the United States Congress. As such, the Army Corps is responsible for ensuring all of these needs are being adequately met. The Kerr Dam is upstream of 2 other privately owned hydropower dams, Gaston Dam and Roanoke Rapids Dam, forming a cascade of dams. This means that any flows released from Kerr Dam that are intended to improve river conditions downstream must also flow through these other dams. As such, any operational changes to the Kerr Dam has to be closely coordinated with the operational rules and hydropower requirements of the dams downstream. Once the Roanoke River flows through the Roanoke Rapids Dam, it flows freely for about 130 miles or 215 kilometers to the Atlantic Ocean. This means that releases from these dams have the ability to impact conditions of the river and river-dependent ecosystems located downstream. As mentioned before, one of the reasons the Roanoke River is so important is that it contains the largest intact bottomland hardwood forests in the region. This forest ecosystem is actually a continuum of different forest types, each of which has a different community structure and have adapted to different flow and flooding regimes. The most frequently flooded areas, located lower on the floodplain, contain swamp forests, while the drier areas that are rarely flooded further up on the floodplain contain dry bottomland forests, and the intermediate area with regular flooding regime contains wet bottomland forests. In recent years, scientists and environmental groups have noticed that this continuum is shifting, with swamp forests expanding up the floodplain and the dry bottomland forests spreading down the floodplain. This is likely due to a change in the size and frequency of flows and floods throughout the year due to dam operations upstream. This shift from a natural flow regime to a regulated flow regime is causing stress and adverse impacts on these forest ecosystems and other sensitive ecosystems. However, these changes can likely be halted or reversed if the flows coming from the dam could be adjusted to create a more natural flow regime, which is the motivation for this environmental flow effort. Before we get into this effort in more detail, I'd like to take a moment to recognize that there have been other types of environmental flows implemented on this river. All of these have been put in place in response to adverse environmental or ecological conditions due to dam release management. The first effort was to ensure that there was enough water for striped bass to spawn in the spring. The striped bass is important to the area from an ecological, recreational, and economic standpoint. While flow augmentation tests have been conducted since the 1950s, permanent spawning releases began in 1995 to achieve target flow rates during the migration, spawning, and downstream movement of striped bass, which occurs between April 1st and June 15th each year. The second environmental flow effort was what is known as the Betterment Plan. This plan was implemented in 1998 in response to hypoxic or dangerously low dissolved oxygen levels in the lower Roanoke River, which were causing large populations of fish to die suddenly, known as fish kills. This phenomena was thought to be caused by a short transition in dam releases between the summer flood releases and the fall low flow releases. During this time, the releases would change from 20,000 cubic feet per second to a few thousand cubic feet per second quite suddenly. When this happened, the river level would drop quickly, and large amounts of water with very low levels of dissolved oxygens in the warm swamp areas would suddenly drain back into the river, killing fish and other organisms. To alleviate this problem, they implemented a slower transition between these two periods, preventing water from sitting too long in the swamps before draining back to the river. The third environmental flow effort that was implemented was the minimum downstream flows for Roanoke Rapids Dam. This is a requirement of the dam's hydropower permit from the Federal Energy Regulatory Commission, put in place to protect the water quality and biological integrity of the river. The most recent levels were established during the relicensing process in 2009. Similar to other environmental flow methods, there are minimum values for different seasons and in normal and drought conditions. All of these environmental flow efforts have also been included as part of the most recent effort to return the natural variability to the lower Roanoke River. This is a good example of how different environmental flow goals can come together piece by piece through learning and adaptive management to provide a more effective management plan over time. Because this effort was launched under the Sustainable Rivers Project, the U.S. Army Corps of Engineers and the Nature Conservancy are two of the main implementers. This site was selected as an SRP demonstration site because the Corps operates the Kerr Dam and Reservoir, and because the Nature Conservancy is involved in the protection of river-dependent ecosystems downstream of the dam, particularly the important bottomland hardwood ecosystems mentioned earlier. Since Kerr Dam is located upstream of two other dams, the owner of those two dams, Dominion Energy, was also heavily involved. However, there were many other stakeholders involved in this process, including over 20 federal, state, local, and non-governmental organizations representing a wide range of interests. They were also involved in the planning process multiple times, including as part of technical working groups, which will be touched upon in the next few slides. Depending on the environmental flow effort, an environmental flow assessment may be completed and published as a separate document. For this effort, the EFA was integrated into the National Environmental Review process required under the National Environmental Policy Act, which was passed in 1969. The act, known as NEPA, requires federal agencies to assess the environmental effects of their proposed actions prior to making decisions. Through this planning process, it was decided by stakeholders that the best way to implement this environmental flow effort was to change the operations at Kerr Dam. As such, the environmental impacts of a variety of alternatives would need to be assessed. While slightly different than some other EFA methodologies, this process also takes into account the flow requirements of a river and its ecosystems, but through a lens of positive or negative impacts from a proposed action. Although 15 alternatives were proposed, the only alternative expected to improve downstream riverine ecosystems was changing the water control plan for Kerr Dam from its current operations to a quasi-run-of-river scheme. This quasi-run-of-river scheme is called such because its purpose is to have the flow of a storage dam, where releases are controlled through management decisions, replicate the flow of a run-of-river dam, where the natural conditions have a greater control over the flow. It is referred to as quasi because the releases are still controlled through management decisions, but it uses flow data coming into the system to mimic natural releases coming out of the system. Through an environmental assessment, the quasi-run-of-river option was found to have a finding of no significant impact, which means that the project can move forward without any mitigation actions. The final environmental assessment was published in May of 2016. While the feasibility study and the environmental assessment were being completed, there was a strong focus on ensuring that different environmental, social, and operational concerns were adequately addressed. To do this, 11 working groups were created to help inform the decision process and determine how to implement the quasi-run-of-river scheme. You'll notice that there are some working groups that are typical for an environmental flow assessment, including flow regime and riparian ecosystems, water quality, sediment and channel morphology, and fish and aquatic resources. There were also other working groups to ensure that social concerns, like water supply and recreation, and operational requirements, like reservoir resources and hydropower, were also included. It is also important to note that all environmental flow projects need to operate within existing policies and procedures to ensure they can and will be implemented. This project created a working group specifically for that purpose, which was important since there were 3 dams, 2 states, and multiple counties involved, all of which have their own legal and management requirements. These working groups contributed to the project by creating detailed analyses for their specific topic, sometimes publishing reports and conducting modeling exercises, and provided formal opportunities for stakeholder engagement. The final outcome of the environmental flow assessment was a quasi-run-of-river scheme and an updated reservoir guide curve. Since releases from Kerr Dam need to flow through both Gaston Dam and Roanoke Rapids Dam, and they are all relatively close to each other, the 3 dams can be thought of as a cascade of dams. This means that flows into Kerr Reservoir upstream will actually require releases from Roanoke Rapids Dam downstream. Because of this, the quasi-run-of-river scheme dictates releases at Roanoke Rapids Dam based on the reservoir elevation in Kerr Reservoir. Here, we have a comparison of their current operations and the new quasi-run-of-river scheme. The new quasi-run-of-river scheme has releases up to 35,000 cubic feet per second based on the weekly inflow into Kerr Reservoir, anytime the reservoir elevation is below 320 feet and above the operational guide curve, which ranges from 295.5 feet to 302 feet depending on the season. In the existing operations, there are numerical releases between 300 and 320 feet in elevation. The new flexibility provided by the quasi-run-of-river scheme means that flows, floods, and pulses occurring upstream now have an opportunity to move downstream. While the weekly averaging of the inflow may prevent short pulses from moving downstream, this does allow the river to move back towards a more natural flow regime, which is the intent of this environmental flow effort. These values were determined through the feasibility study and detailed planning process, including consultation with the technical working groups, and are considered to be the maximum extent of what could be changed operationally without drastically altering reservoir levels and flooding downstream. Through the NEPA process, environmental impacts were required to be assessed due to the implementation of the quasi-run-of-river scheme. Although 18 types of resources were evaluated for potential impacts, there were no significant impacts on most resources. In general, the potential benefits included long-term ecological improvement in the lower Roanoke River floodplain, including improvement in the diversity of vegetation. The potential adverse impacts from the project were predicted to be a 3 to 4% loss in hydropower generation, which could be replaced by an energy generation method dependent on burning fossil fuels, and more frequent flooding for agricultural and forestry lands downstream. From a cumulative impact perspective, the potential adverse impacts were regarded as generally minor and outweighed by the potential benefits of downstream ecosystem restoration. During the times of year when the quasi-run-of-river scheme is in effect, the weekly average inflow into Kerr Reservoir will determine the outflow at Roanoke Rapids Dam. These values will be calculated using 2 methods. The first method uses flow data at 3 stream gauges upstream operated by the United States Geological Survey, along with a local hydrograph to determine the flow going into Kerr Reservoir. The second method is to monitor the changes in the elevation of Kerr Reservoir, as well as the outflow of Kerr Dam, to determine the inflow to Kerr Reservoir using a water balance equation. These two methods are automatically calculated and checked against each other for accuracy. To make sure the correct amount of water is being released, another USGS stream gauge is being used, which is located 3 miles downstream from Roanoke Rapids Dam. The new water control plan for Kerr Dam was finalized in June of 2016, and these new operating rules have been in place for only a short time. While we will discuss monitoring and adaptive management in greater detail in week 14, I'd like to say a few words about how this project is accomplishing those two. Monitoring for environmental flows can be thought of as two types: compliance monitoring, which is, are the intended flows actually being met? And effectiveness monitoring, are these flows accomplishing our ecological and/or social management goals? For this project, compliance monitoring is built into the environmental flow implementation using the USGS stream gauges. Effectiveness monitoring for this effort would require some ecological monitoring to see if there are any changes in the bottomland hardwood or other sensitive ecosystems downstream. While the Army Corps does not have any plans to conduct monitoring, it is likely that other environmental organizations, like the Nature Conservancy, and environmental agencies, like the United States Fish and Wildlife Service, will conduct their own ecological monitoring that could be shared and analyzed. For adaptive management, it is often recommended to evaluate monitoring data and impacts from a new management action regularly. For this project, there is no requirement for periodic evaluation. However, the Army Corps is open to adjustments in management practices, which is critical for implementing environmental flows. This can be seen in the fact that this is their fourth permanent environmental flow effort since the 1990s. As long as there are other governmental and non-governmental organizations willing to monitor and bring up important concerns with the Army Corps, adaptive management principles can continue to improve the condition of the Roanoke River. Here are the references used for this case study. I encourage you to read both of these documents to find out more about the quasi-run-of-river scheme on the Roanoke River and how the Sustainable Rivers Project is working towards implementing environmental flows on a countrywide basis. Both of these documents are located in the Additional Readings folder for this course. There are a few take-home messages from the Roanoke River case study. For this effort, there was enough flow to meet the required management objectives, and what was needed was a change in the management of those flows. This is different from a river basin that is already overallocated, and there is a need to find water to put back into the river. In addition, this dam scale implementation example shows that improved management of the river at one site upstream can have an impact on the conditions downstream. There were positive results from the Army Corps' previous environmental flow attempts, and we hope to see the same results with this effort. The Roanoke River is an example of how different types of organizations can work together to implement environmental flows. And finally, environmental flows can be implemented in pieces and over a long period of time, as long as there is an adaptive management mindset. The Sustainable Rivers Project began working in this river in the early 2000s, meaning that this effort took decades to accomplish. But the outcome, combined with the existing environmental flow efforts on the river, means improved water resources management and greater stakeholder engagement moving into the future. This is the end of the case study. Thank you for your attention.